One thing I wanted to talk to you about is graphing. Make sure that you always title your graphs so that the reader knows what they're looking at. Another thing to do, make sure you have labeled both axes. So maybe if it's a position time graph, you might label position and time. And your increments should be pretty consistent. One thing I don't want to see is like skipping to a little zigzag from statistics or whatever you guys use. I don't want to see that, because what that does is it takes your numbers, or it takes the shape of the graph that would have been, and it will scrunch it down. And so you might end up with something like that. So it can cause something to look flatter than you actually intended it to look. As far as sketching and plotting goes, if I ask you to sketch a graph, I just want the general shape of it. So I just want to be able to see trends and important parts. So if it's supposed to be a straight line, give me a straight line. If it's supposed to be flat, give me a flat line. You are allowed a straight edge on the AP test, so use it, please. If it's supposed to be quadratic, give me a parabola or half a parabola or whatever it's supposed to be. If it's supposed to be logarithmic, give me a logarithmic graph. If it's supposed to be a square root graph, you can give me one of those. Just the shape of the graph is pretty much all that matters with sketching. You might want to mark or label your like maximums or your minimums. So maybe the highest this is going to go is going to approach 50. So we may want to label the asymptote there. Maybe you need to label intercepts. So you might tell me what point this is. So give me important points like that. When it comes to plotting a graph, that's different. When I say to plot a graph, what I mean there is that you need to give me all the data points and a trend line, so your best fit. So maybe these are your data points. Your best fit, as a rule of thumb, should touch as many as possible points, but it should have the same number of points above as below. Another thing you want to keep in mind, you don't want to make a best fit line that creates an outlier. The deviation, the standard deviation, kind of depends on the distance from the line, or rather it depends on the square of the distance from that line. So you want all the points as close as possible. You don't want to create any outliers. So this would be a good best fit line. Maybe this one's another one, something like that. As far as getting the slope of a line, you do not use the data points from your table. To get the slope of a line, you need to use points on your best fit. So I'll go back to the original best fit. So I would pick points that are convenient for you. And so if this is point A and point B, your slope needs to come from the line. So and that'll get you your slope. One thing you don't want to do is make your best fit. You don't want to force your best fit through 0, 0. You don't have to do that. If we're linearizing something, which I'll talk about later, you'll need that to go through the origin, but not for best fits. So for generic graphs, it doesn't need to happen. If we're linearizing a graph, though, we'll need that.